we want to go through one more example. And we did yesterday, these didn't save, but we did those yesterday, right? Yeah, okay, that's what I thought. So here's the last one we want to go through. This is a tough one. There's a lot going on with this one, right? But our goal is to solve for h. Okay, can you point to a single h? We did this one yesterday? Really? We didn't finish it though? Okay. We didn't quite get it. Okay, so we already started it though. So we agreed we could point to a single h, right? Okay. So our goal is, because we can point to a single h, all we have to do is isolate it. So the first step is there anything I need to add or subtract to both sides to get that h by itself? Okay, there is. There is something. And phone should be away, please. It should be a big something in this case. What do you think, CJ? It's this whole term, 2/3 pi r cubed, right? That whole thing. Look how that's connected. Here's my h. Here's my h, and I've got this plus sign here. All of this stuff is connected to the h by addition, right? It's being added to the term that contains the h. Everybody agree? So I want to undo that. I got to get rid of that term, because I'm trying to, every step I take when I'm isolating, I should be crossing stuff off of the side of the equation with the h in it and pushing it over to the other side somehow. Okay, so isn't that first step then? That first step, oh, I didn't want to do that. Hang on. The first step is going to look like that, right? I'm just going to subtract that whole big term from both sides, and then it cancels from the side that's got the h. That's good. Then on the side with the h, look, I've got much less there. That step accomplished a lot. I got a lot pushed away from the h, right? On the other side, on the left side now, I've got something that looks pretty ugly, but we don't care. It's all right. I mean, it can be ugly. Answers don't have to look really simple. Sometimes they look pretty bad. Okay, now what? Trying to get that h by itself. Well, working my way up the ladder here, what's being done to the h that I have to undo to isolate it? Say it again. Subtract. Are you looking at r squared? Okay, but now is it being added to h? It's being multiplied, right? So I undid addition by subtracting. How do I undo multiplication? By dividing. There you go. So I'm going to have to divide both sides by r squared to get rid of that one. What else? The pi's being multiplied, isn't it? So I could divide each side through by pi. Okay. Now the 4/3, we could multiply by the reciprocal if we want to. That's fine. But let's take it in separate pieces. The 4 is being multiplied, so I could divide by the 4. What about that 3? The 3's on the bottom. How do I undo dividing by 3? Multiply by 3. So we could do this in any order. The way I chose to do it is in this order. It didn't have to be, though. It didn't have to be. We could have easily done what Easton suggested first, but I just decided when I was doing this, let's get rid of the 3 first. So I'm going to multiply each side by 3 to cancel the 3's over here. I did it in 2 steps, okay? So what happens on the other side? Well, when I multiply the whole left side by 3, I have to distribute, right? So I get a 3v, and then when I multiply the 3 times the 2/3, the 3's cancel, right? So then would everybody agree at this point, after I multiply by both sides by 3, this is looking better, right? It's even closer to being by itself. We're getting closer to isolating the h. The left side ends up looking like that now. Give me thumbs so far. Okay? So now we're just going to do what Easton was suggesting. Now we got to undo the multiplication by dividing, but we can do it all at once. We don't have to do it separately. The h is being multiplied by 4 and by pi and by r squared, right? So why don't we just divide each side through by all that stuff? So I cancel the 4's, I cancel the pi's, and I cancel the r squareds. And then on the left side, I end up with something that looks pretty ugly, but that's all right. That's my answer. Okay, it's a formula. It works. I've got h written in terms of v's and r's, right? Those are the other. So presumably this is some formula where I'm going to plug in values of volume. V is probably for volume, and R is probably for radius or something, right? So I'm plugging in values for V and for R to predict a value for H.